So it says Tarzan of mass 80 kg swings from rest on a rope of length 10 meters that is horizontal when he starts, as shown in the diagram below. At the bottom of his swing, he picks up Jane, sitting on the ground in an inelastic collision. Jane has a mass of 50 kg. They then swing upwards as one unit, and the mass of the rope on the effect of air, the mass of the rope and the effect of air friction may be ignored. So this Tarzan there with 80 kg is going to be swinging and collecting Jane. So in this instant, right, yeah, we can see that he's in the air, right? So something about him in the air tells us something about the type of principle of energy that we're going to use, right? So there are a lot of principles of energy. There's mechanical energy, there's potential energy, there's momentum, right? But whenever an object is in the air, always understand that we need to use mechanical energy, right? Because mechanical energy just means potential energy plus the kinetic energy. And we know that something is in the air, right? It has the potential energy. Just like if I leave my book in the air, it has potential energy because when I release it, that potential energy can then move to kinetic energy, right? So whenever something is in the air, right, we should always visualize that, right? So state the principle of conservation of linear momentum in words that we can do. And then it says 18.2, right? Calculate the combined speed of Tarzan and Jane just after he picks her up, right? So the formula that we'll be looking at, right, in this case is just the conservation of momentum, right? So let's write that down and see where we can get, right? So I'll use a pen. Let's just make it like that. So that's fine. And just use a white color. It can be clear, right? So we know that sum of momentum initially is equal to the sum of momentum finally, right? So we know that we have mv, right? Let's just say MAVA, right? Plus MBVB, right? Is equals to, remember these people move off together, right? So it says at the bottom of his swing, he picks up Jane sitting on the ground in an inelastic collision, right? So when they meet, when they collide, right, Tarzan goes with her, right? So we'll be using the combined mass. So it means that whatever velocity that they will be traveling, right, they'll be traveling it together because now they are one. Because just after he picks her up, that's when they travel together, right? So on our final side, right, we're going to have the sum of those masses, MA plus MB, right? Because now they are one, right? They're picking each other. Tarzan is picking her up, right? So they act as one system, right? And then our final velocity, right? That's what we don't know, right? So let's look at the things that we know, right? So the things that we know, we're gonna underline them with green, right? Is that okay? All right. So the mass of A, let's say A is Tarzan. All right. We have that. We have the mass of A. The V of A, we do not have. The mass of Jane, we have that. The velocity, initial velocity of Jane, right? We also have that because we know that she was just sitting, right? And if she's sitting, it means the velocity is 0. So we have that as well. And then the mass, both of the masses we have, right? But also, this is what we're calculating, VF, right? So there are two unknowns in this equation, right? So there are two unknowns. So we don't have this here. We don't have this. We also don't have this, right? And we cannot have two unknowns, right? And look for what we're looking for, right? So we have to have one unknown. But if I take a bit look at this, right? So Tarzan is in the air, and we spoke earlier about mechanical energy, right? So when he's in the air, there's something called mechanical energy, right? Mechanical energy, which is the sum of the kinetic energy and the potential energy, because whenever something is in the air, right, it has the potential energy, right? It has the potential to move and gain kinetic energy, right? So let's try and use mechanical energy to find this VA, right? Because if we find VA, we have everything, right? And we only have one unknown, which is going to be our VF, right? So let's go farther away, right? And then let's work somewhere around here, right? So just resize that. Let me just use a white pen. Right, let's take this question. Right, so we are looking at Tarzan, right? Because Tarzan is the one that we're looking for his initial velocity. Because Jane, we have her initial velocity, we also have her mass, right? So the only thing that we should think, give velocity are this guy called Tarzan, right? Just before he picks her up, right? And we need to use mechanical energy because he's in the air. You understand? So he's in the air, we're going to use mechanical energy, sum of mechanical energy, right? So sum of EM, just going to call it EM, right? of EM, right, is equals to sum of EM. So this is the conservation of mechanical energy, right? And once we've got that jotted down, let's continue, right? So we know that EM, right, which is mechanical energy, is the sum of the potential energy, right, plus the kinetic energy, right? Potential energy plus kinetic energy, right? So once we have that, right, we need to understand something, right? What are we actually looking for here? What we're actually looking for, right, is the V of Tarzan, right? But if you look at it properly, right, we have his mass, right? And in this case, right, if we can find his kinetic energy, right, because we know that EK, right, is the same thing as 1 over 2 mv squared, right? So if we can find his EK, right, we can take that EK, right, and equate it to this formula because we have the mass, right? And our only unknown is going to be the velocity, right? So let's make it our mission to find EK final, right, of this, right? So let's make it our mission to find EK final, right? So let's proceed. EP, we know that it's mgh, right? It's on the formula sheet, plus 1 over 2 mv squared, right, is equals to mgh as well on that side, plus 1 over 2 mv squared, right? And we know that this side, obviously, this is our initial side, this is our final side, right? So let's take a look at this, right? That's fine. Our mass of Tarzan, right, it remains as 80, so we'll replace 80. Our G is obviously our gravity, which is 9.8. And initially, Tarzan, right, if we look at Tarzan, he's at a height of 10 meters, right? His height is 10 meters, right? So our height there, we're going to put it as 10, right? In brackets. And then we're going to have 1 plus, right, 1 over 2. His mass is still 80, right? And then his velocity at this moment is 0. Reason is because he was in the air, right? That was just before he jumped. I mean, just before he swung, right, and collected Jane, right? I hope you're getting it. And then is equals to mgh. Finally, on the final side, his mass is still the same. He's still 80 kg, I meant to say. And then our gravity always stays constant as long as we're on Earth, 9.8. And his height, right? So look at this. What we are actually looking for, right, is actually what we're looking at, right, is the final, right? Since we're looking at mechanical energy, right? So the first side, the left-hand side, we dealt the mechanical energy when he was in the air, just here in the air, just as he was here. Let me just change the color, right? Just as he was in the air. This is where we're looking at him, right? And we got our height as 10 meters, right? But what we're actually looking for is our kinetic energy, right? So our mechanical energy on the right, has to be just before he catches her, just before. So we're looking for the speed, right? So just before he catches her, he's going to be somewhere around here. This is Tarzan. I'll just call this T, right? And at that point, our height is no more 10 meters, right? But it's 0 because it's just before he catches her, right? So it's our height goes back to 0, right? Our height is 0. So let us just replace that. Take it back to a white color. Our height is 0, right? Plus obviously 1 over 2. Our mass is still 80. Right, hold on. Right, so we don't even need to do this. Let me just increase the size of that. So we don't even need to increase this and to fill in that, because that's what we're looking for, right? So this 1 over 2 mv squared, we do not change it. We can just keep it as our EK, right? Our EK, right? So because that's what we're looking for, that's what we solve, that's what we're trying to solve, right? And then after we find our EK, we can go back to the formula 1 over 2 mv squared, and therefore proceed by getting our velocity of this guy, right? So it's that plus EK, right? So we don't need to fill in those values, because we are looking for EK anyways, right? So of course here we can just type on our calculator 80 times 9.8. So right, so we type that on the calculator. 80 times 9.8 times 10 gives us 7,840. And of course, this product is going to give us 0 because we're multiplying by 0 anyways. And also this is going to give us 0. So we just leave it like that. And then it's equal to EK, right? So now look at this. We found our EK, right? So our EK, right? So this is the kinetic energy of this guy just before he hits her, right? Just before he picks her up, right? Instead, I could say that. And then, so what we actually want to do, right, with this EK, like we discussed, we want to actually use this formula and then get his velocity, right? Right, let's do that now. EK, right? We know our formula is 1 over 2 mv squared, right? Our EK, we got it as 7840, right, is equals to 1 over 2. His mass is still 80. The velocity we still don't know because that's what we're looking for, right? And right, yeah, so we can proceed here further. Right, so here it's going to be 1 over 2 times 80 is going to give you 40 v squared, right? It's still equal to 7840, right? And then we divide both sides by 40. Right, if we divide both sides by 40, right, so we're going to get 196 on this side is equals to v squared, right? So we're looking for v, not v squared. So we square root both sides, and then our v, right, the velocity of this guy, right, is going to be 14 meters per second, right? So yeah, voila, we got our velocity of this guy, right? So the initial velocity of this guy, so it's 14 meters per second, right? So we can now move forward, right? So now we can even change. We also have that now, right? Sort of sorted. And then, yeah, the rest is history. So we're just going to replace into that formula, right? His mass is 80. His velocity, we just calculated, is 14, right? Plus the mass of the girl, it's 50, right? Multiplied by her velocity. Initially, she was still sitting, right? So it's 0, is equals to the combination of their masses, right? So it's 80, which is the combination of Tarzan, plus the mass of, the mass of Jane, which is 50, right, into VF, which we still don't know, which is what we're calculating, right? So you'll forgive me, this thing is a bit messy here. So let me just try and clear a lot of stuff here. Right? Yeah, so we can proceed with that. So we have 80 times 14, 80 times 14. Type that on my calculator, it's going to give me 1120, right? And then 50 times 0 is just going to give us 0. And then here we have 80 plus 50, it's 130, right? 130 VF, right? Which is what we're looking for. So we divide both sides by 130 to just get VF on its own, right? Divided by 130. And then we get our VF as 8,62 meters per second. And then, yeah, so that's what they asked, right? So you calculate the combined speed of Tarzan and Jane just after he picks her up, right? So we do not need to give a direction because it just asks for speed, right? And speed is a scalar quantity, right? So scalar quantity only has magnitude, so we can leave it like that, right? And 18.3 asks, will Tarzan and Jane reach a height of 10 meters on their upward swing? Give a reason for your answer, right? So in the information box, they've actually given us the answer. They said that this is an inelastic collision, right? So if it's an inelastic collision, it means that obviously they won't reach that height, right, that was initially there, right? Because in an elastic collision means that the kinetic energy is also conserved, not just the momentum, but also the kinetic energy is conserved, right? So that this won't reach a height of that because this is an inelastic collision. And then it says 18.4, if Jane is holding onto a bag of bananas at the time when Tarzan picks her up, how will their combined speed compare to that in question? So here, Jane is no more going to be 50 kg. She's going to weigh more, right? Because she's holding a bag of bananas, right? So we know that obviously if you are heavy, you won't reach far. You understand? It's very, very hard to push a heavy person than it is to push a lighter person, right? So yeah, this was just the combined speed will be smaller than, yeah.